We all know trigonometric functions are sine x, cosine x, tangent x, secant x, cosecant x, and cotangent x. So those are all trigonometric functions. So the derivative of sine x is simply cosine x. The derivative of cosine x is negative sine x. By all means, these are the only identities that you have to know, because you can derive the other derivatives as long as you know these two. What do I mean by that? If I have to find the derivative of tangent of x, that is simply the derivative of sine x over cosine x. Now that is one function divided by another function, so we could use quotient rule. U is sine x, v is cosine x, so u is equal to sine x, v is cosine x, u prime is cosine x because I just mentioned that the derivative of sine x is cosine x. V prime is negative sine x because the derivative of cosine x is negative sine x. So if we use quotient rule, the derivative of tangent of x would simply equal to v u prime minus u v prime divided by v squared. So v is cosine x, u prime is cosine x, u is sine x, v prime is negative sine x. Divided by v squared, we would simply have cosine x squared. The numerator would then become cosine squared x plus sine squared x divided by cosine x squared. But we know the identity that cosine squared x plus sine squared x is 1, so we have 1 over cosine x squared. And that can be written as 1 over cosine x squared. And we know 1 over cosine x is secant x. So the derivative of tangent x is simply secant squared x. So let's do derivative of secant x. Derivative of secant x can be derived by saying derivative of 1 over cosine x. Again, using quotient rule, if u is 1 and v is cosine x, u prime is 0 and v prime is derivative of cosine x, which is negative sine x. So if we use the rule, the derivative, quotient rule, derivative of secant x would be equal to v u prime minus u v prime divided by v squared. V is cosine x, u prime is 0, u is 1, v prime is negative sine x, divided by v squared, which is cosine squared x. which we could write it as sine x divided by cosine x times cosine x. But if we realize that we can split this expression, we could write it as sine x over cosine x times 1 over cosine x, which would simply give us secant x times tangent x. And that would be the derivative of secant x. Let's find the derivative of cosecant x in a similar manner. Cosecant x is simply 1 over sine x. And if I define u as 1 and v as sine x, the derivative of u is 0. The derivative of v is cosine x. Using quotient rule, we have v u prime minus u v prime divided by v squared. V is sine x, u prime is 0, u is 1, v prime is cosine x, divided by sine squared x. Using the same technique that we did before, we could write this as cosine x over, or negative cosine x, over sine x times sine x. If we split it up, we have negative cosine x divided by sine x times 1 over sine x, which would simply give us negative cosecant x times cotangent x. Now you should sort of recognize a pattern and realize what the derivative of cotangent x would be. So the derivative of cotangent x would simply be the derivative of cosine x divided by sine x. If we use quotient rule, we could set u to be equal to cosine x and v to be equal to sine x. U prime would be cosine x, or the derivative of cosine x, which is negative sine x, and the derivative of sine x is simply cosine x. Using quotient rule again, the derivative of cotangent x is simply v u prime minus u v prime divided by v squared. V is sine x, u prime is negative sine x, minus u is cosine x, and v prime is cosine x, divided by sine x squared. So we have negative sine squared x minus cosine squared x divided by sine squared x. I have a negative in common, so negative sine squared x plus cosine squared x divided by sine x squared. Using the identity, we have negative 1 over sine x squared, which would simply give us negative cosecant x squared. So as I mentioned, you don't have to memorize every single derivative. If you know one, you can, of course, derive, but these days you have table of derivatives and a table of integrals, so you could just use those tables. So here we have two functions, which is the product of x cubed and sine x, and u would be x cubed, v would be sine x, u prime is 3x squared. The derivative of sine x is cosine x. So using the product rule, f prime of x would be u v prime plus v u prime x cubed times cosine x plus v is sine x times u prime, which is 3x squared. We have an x squared in common, so if we pull that out, we have x cosine x plus 3 sine x. So f of x here is sine x times cosine x, and if we set u as sine x and v as cosine x, u prime would be cosine x, v prime would be negative sine x, and f prime of x would be u v prime plus v u prime. So sine x times negative sine x plus cosine x times cosine x, which would be negative sine squared x plus cosine squared x. So the answer is cosine squared x minus sine squared x. Here we have the product of e raised t multiplied by cosine t. So the dependent variable is u and the independent variable is t. I don't want to call u in my product rule because u is the dependent variable. So I'm simply going to call e raised t as p and cosine t as v. So u prime of t is p v prime plus v p prime. So p is e raised t, v is cosine t, p prime is e raised t, v prime is negative sine t, based on our derivation. So u prime of t would equal to e raised t times v prime, which is negative sine t, plus v, which is cosine t, p prime is e raised t. We have e raised t in common, so if we pull that out, e raised t would come out and we would have negative sine t plus cosine t, which I'm going to rewrite it this way. I don't like to start with something negative, so cosine t minus sine t. So here we want to find the derivative of g of t, which is equal to secant t multiplied by cotangent t minus cosecant t. So g is the dependent variable, and t is the independent variable. So u is secant t and v is cotangent t minus cosecant t. So u prime, the derivative of secant t is secant t times the tangent t, which is what we derived. the value of v is cotangent t minus cosecant t, we know the derivative of cotangent t is 1 over cosecant t with a negative. The derivative of cosecant t is negative cosecant t, the derivative of cotangent t is negative cosecant squared t, and the derivative of cosecant t is negative cosecant t times cotangent t. If I combine, I would have negative cosecant squared t plus cosecant t times cotangent t. I have a cosecant in common, so I'm going to pull that out. Cosecant t minus cosecant t plus cotangent t. Now I could use the product rule. That would be v prime. G prime of t is equal to u v prime plus v u prime. U is secant t. V prime is cosecant t minus cosecant t plus cotangent of t, plus v is cotangent of t minus cosecant t multiplied by u prime, which is secant t times tangent t. So u is, did I make a mistake? I think I did. Oh. U is simply secant t. I'm sorry. And v prime is, never mind. I just skipped a step. So secant t times cosecant t. So I was right at the beginning. Could we simplify this in some form? Let's distribute. We'll have secant t times cosecant t squared with a negative. Secant t times cotangent t. Cotangent t times secant t times tangent t minus cosecant t times secant t times tangent t. If we write it in terms of sines and cosines, we'd have 1 over cosine t multiplied by sine squared t, 1 over cosine t times cosine t over sine t plus cosine t over sine t times 1 over cosine t times sine t over cosine t minus 1 over sine t times cosine t, 1 over cosine t multiplied by sine t over cosine t. I'm trying to simplify and write it in terms of sines and cosines, so those two terms would get cancelled. those two terms would get cancelled, those two terms would get cancelled, those two terms would get cancelled. So I'd simply have negative sine squared t over cosine t plus 1 over sine t plus 1 over cosine t minus 1 over cosine squared t. This term and that term have a common denominator. So if I combine, I'd have 1 minus sine squared t divided by cosine t. I could write 1 over sine t as cosecant t, 1 over cosine squared t as secant squared t. 1 minus sine squared t is cosine squared t using the trigonometric identity that sine squared t plus cosine squared t is equal to 1. I mentioned this earlier at the beginning of the video. So I would have cosine squared t divided by cosine t plus cosecant t minus secant squared t. I could cancel one of the cosines, so the answer would be cosine t plus cosecant t minus secant squared t. So you could have a very lengthy expression, but if you can convert it to sines and cosines, you can see how the answer reduced to a very simple expression. You may ask me why. Well, if we have to take the second derivative, it is easier if we start here rather than starting there. You're going to make it extremely hard on yourself. So here we have one function divided by another. So we have to use quotient rule. I'm going to call that u and that as v. So u is sine t minus cosine t. V is sine t plus cosine t. U prime is cosine t, derivative of sine t is cosine t, derivative of cosine t is negative sine t. V prime, derivative of sine t is cosine t, derivative of cosine t is negative sine t. So quotient rule suggests that the formula is v u prime minus u v prime divided by v squared. V is sine t plus cosine t. U prime is cosine t. Negative times negative is positive, so plus sine t. Minus u sine t minus cosine t multiplied by cosine t minus sine t divided by sine t plus cosine t, which is v, and squared. Do not leave it as is. Let's see if we can simplify this. Again, if you have to take the second derivative, and if you started here, you're going to make it hard on yourself. So let's see if we could simplify first. So if I distribute, I'd have sine t cosine t plus sine squared t plus cosine squared t minus sine t cosine t minus sine squared t minus cosine squared t plus sine t cosine t. So distribute that negative, we have sine t cosine t. We know that sine squared t plus cosine squared t is 1. Distribute the negative, we have negative sine t cosine t. Negative would be positive sine squared t, positive cosine squared t, negative sine t cosine t, divided by sine t plus cosine t squared. So that term and that term would go away, and we have sine squared plus cosine squared, sine squared t plus cosine squared t equaling 1. I already have 1 here, so 1 plus 1 would be 2 minus sine t times cosine t divided by sine t plus cosine t squared. Here we have a problem where we have to find the second derivative of g of s. The dependent variable is g. The independent variable is s. And naturally we have to use the quotient rule. So let's start with the first derivative. U is e raised s plus sine s. V is e raised negative s minus cosine s. U prime is e raised s plus cosine s. V prime, we know the derivative of e raised negative s is negative e raised negative s. The derivative of cosine s is negative sine s. So we end up getting negative e raised negative x plus sine s. So f prime of x would be v u prime minus u v prime divided by v squared. V is e raised negative x minus cosine s multiplied by u prime e raised positive s plus cosine s minus u is e raised s plus sine s multiplied by v prime negative e raised negative s plus sine s divided by v squared, which is e raised negative s minus cosine s squared. I don't want to go to the second derivative because I didn't do chain rule. So let's just stop at the first derivative. Distribute and simplify e raised negative x times e raised s plus e raised negative s times cosine s minus e raised positive s times cosine s minus cosine squared s minus e raised s times negative e raised negative s e raised s times sine s minus e raised negative s times sine s plus sine squared s divided by e raised negative s minus cosine s squared. The first term is going to reduce to 1 plus e raised negative s cosine s minus e raised positive s cosine s minus cosine squared s. Distribute the negative. That is going to become negative 1, so negative times negative is positive 1, negative e raised s sine s, positive e raised negative s sine s, negative sine squared s, divided by e raised negative s minus cosine s squared. Unfortunately, things may not simplify here much. So 1 plus 1 is 2. I have a term with e raised negative s and e raised negative s, so I could pull e raised negative s out, which would give me sine s plus cosine s. I have a term with negative e raised cosine s, or negative e raised s times or minus negative e raised s times sine s. Those two have e raised s in common. So if I pull negative e raised s out, I have sine s plus cosine s. And lastly, I have negative cosine squared s and negative sine squared s. If I pull that out, I have sine squared s plus cosine squared s. I'm going to pull the negative out and divide by e raised negative s minus cosine s squared. But we all know that that is 1. So we have 2 minus 1 plus sine s plus cosine s is common between those two terms. So if I pull that out, I have sine s plus cosine s multiplied by e raised negative s minus e raised positive s divided by e raised negative s minus cosine s squared. So 2 minus 1 is 1, so we have 1 plus sine s minus cosine s multiplied by e raised negative s minus e raised positive s divided by e raised negative s minus cosine s squared. Quite a lengthy problem. So here we want to find the derivative of cosecant t times cotangent t plus sine t. So we have two parts. So we have to use product rule for that part. and a direct derivative for sine t. So d over dt of cosecant t times cotangent t, derivative of sine t is simply cosine t. So the derivative of cosecant t, cotangent t, we have to find it using product rule. So that would be u, and that is v. We know the derivative of cosecant t is negative cosecant t times cotangent t. The derivative of cotangent t is negative cosecant squared t. So we have d over dt cosecant t times cotangent t is equal to uv prime plus vu prime. Cosecant t multiplied by negative cosecant squared t plus cotangent t multiplied by u prime negative cosecant t times cotangent t, which would reduce to negative cosecant cube t. Cotangent t times cotangent t is cotangent squared t, so minus cosecant t times cotangent squared t. Don't forget that that is not the answer. That is just the derivative of that part. So we have to plug it back in. So we already have it here. So negative cosecant cube t, negative cosecant t, cotangent squared t plus sine t would be the final answer. So here we have a function where we want to find the first derivative. We have to use quotient rule because the numerator has sine x. So we call it u. Denominator has 1 plus sine x. So we have e. So u is sine x. V is 1 plus sine x. U prime is cosine x. V prime, the derivative of 1 is 0, and the derivative of sine x is cosine x. So y prime is v u prime minus u v prime divided by v squared. V is 1 plus sine x. U prime is cosine x. U is sine x, and v prime is cosine x, divided by v squared, which is 1 plus sine x squared. Distribute and simplify, we would have cosine x plus sine x cosine x minus sine x cosine x divided by 1 plus sine x squared. Always try to simplify, because if we have to find the second derivative or the third, if you don't simplify, you're going to make it hard on yourself. So the final answer is cosine x divided by 1 plus sine x squared.